Hello students, in this video we'll look at these two examples, 11.20 and 11.21. Let's start. Okay, Adrian, Billy, Catherine, and 4 other students are arranged randomly in a row. And then what are the probabilities that these 3 students, and then you have the A part and B part. Okay, so first of all, again, we have some understand the question first. Now we have Adrian, Billy, and Catherine, and also 4 other students. So first of all, we understand we have total 7 students. Okay. So now we go to part A. Now what are the probabilities that Adrian, Billy, and Catherine are standing next to each other? So P, they stand next to each other. So let's try to look at what means next to each other. Means you have now 7 students stand here in a row, and then Adrian, Billy, and Catherine need to stand together. So you get this 3 together to put Adrian, Billy, and Catherine, and these 4 are other students. Others. So first of all, you can get the denominator first. Now you stand in a row means the order is matter. So we use the concept you learn in permutation. Now 7 students, you need to arrange them, so you get 7 factorial. And now we look at our case. Here you get these spots, and then you get this 4. So these spots, and you get this 1, 2, 3, 4, and you can arrange this. So you get 5 factorial. And then for this A, B, C, you can also arrange them themselves. So you get 3 factorial. So the number of arrangement is 5 factorial times 3 factorial. You should learn this in chapter 10 already. So you get the answer 1/7. Now we go to part B. Stand alternatively with other students. You understand the question first. Here, alternative means you get student, and then this 4 we put the other students, and then ABC means Adrian, Billy, and Catherine. You need to put here, and you cannot put here, because you need to alternate it with other students. Means other students and then one of them, and then other students and then one of them and other students. Just imagine you will pick this, for example, you pick these 3, then they are not alternative with other students, because here you will have 2 other students stand together, but not alternatively. So this is not work. So let's get back this. Then you need to have A, B, C putting in these 3 spaces. So now we get the answer: stand alternatively. Alternatively. The denominator again is the same, 7 factorial. So now for these other students, you get 4 factorial, right? And then for ABC, you have 3 factorial. So the numerator is 4 factorial times 3 factorial. And then as a result, you get this answer. Okay, let's go to the next example. This is actually a little bit more complicated, so let's be more focused in these questions. There are 10 clubs in a school, and 2 students are nominated from each club to join a leadership training camp. So, total, how many students are nominated? Yes, it should be 20. And then from these 20 students, 4 students are chosen at random, and then find the probabilities at the following. So now, the case is you get 10 clubs, okay, and then 2 students from each club. So total, we will have 20 students. Okay. Okay, if we use like A to represent club A, then you have 2 students, okay, selected from club A. So you have like A1, A2. So, okay, this represent those 2 students nominated, okay, from club A. And then similarly, we get B1, B2, C1, C2. Okay, let me just simply write down all. Okay, F1, F2, G1, G2, H1, H2, I1, I2, and J1, J2. Okay, so total we have 20 students. And now we are going to find the probability that these 4 students are from exactly 2 clubs. Okay, probability from exactly 2 clubs. So now, first we choose 4. We choose 4 from these 20 students, right? 4 students are chosen. Okay. So in the denominator, you get 20. C4. Okay, and for the numerator, actually, what is the number of combination you will get? Okay, if those 4 students are accepted from 2 clubs. Okay, first of all, you need to like count the number of clubs. Okay, different clubs. Okay, you will have, like, for example, you have AB clubs or you have AC clubs. Okay, like this. So you simply choose from A to J, right? From A to J, you have 10 clubs, right? And then we choose 2 out of them. Like you have AB or you have BC or you have EH, like that. Then it should be 10C2. Okay, and after you choose 2 clubs, okay, the next one is you need to choose the students from the clubs, right? So, for example, you take AB and then you need to take both students from A, right? Because total you need to pick 4 students. So you will have 2C2 times 2C2. Okay, the first one is from the club, from the first club, okay? Club 1, and this is choose from the club 2. I need to take both. So this is the number of combinations for pi. So finally, you will get 3 over 323. Actually, it is quite small, the probability, because they need to be exactly 2 clubs, so it is not easy, right? Okay, So now part B, all from different clubs. So just apply the same idea. Okay, so first of all, denominator is 20C4. And now, if those 4 students need to come from different clubs, so they should come from how many clubs? First of all, you just imagine A to J, right? Because these 4 students need to belong to different clubs, so they should come from 4 clubs, right? So this time we have 10C4. We first choose 4 clubs out of this 10. Okay, and then in each club, we only need to pick one of them instead of 2 this time, right? So actually we have some choice. We have 2C1, and this is for club 1, and then you get 2C1 for club 2, 2C1, and then 2C1. So finally, you will get 4 2C1 here. And as similar to part A, this is from club 1, and this is from club 2, and this is from club 3, and this is for club 4. Okay? And that is the answer, which you will get 224 over 323. Okay, you will find that as the number is quite big, okay, at least it's more than 50%. So it is quite easy to get 4 students from different clubs because there are 10 clubs. Now you just have 4 students, right? Okay, so this kind of thinking skill is quite important in this kind of question. And also, you should also can try to imagine whether it is like reasonable to have such a number of probability. That means whether it is the number is too big or too small, like that. Okay, so let's try to do quick practice 11.20 and 11.21. They are similar to these examples, and I hope you can get familiar with that. Okay, so see you